Welcome, friends, to another great day of learning. Today, we shall continue learning. This is day 12. We have looked at how to create a cluster. We have looked at how to deploy an app. We have looked at how to explore our app, exposing our apps. And today, we're now going into scaling our Kubernetes apps. And that's tremendous progress that we have had over the past I can say a week or so, and very soon we shall only increase on our success and get very better. So let's get into this. Running multiple apps of your right. I need to revise English. Okay, it's saying running multiple instances of your apps. I was reading it as running multiple apps of your instance. Crazy. So, all right, running multiple instances of your app. Objective: scale an existing app manually using kubectl. And if you're watching this for the first time, know that there are about 11 videos of us studying Kubernetes. So if you watch this and many things are not familiar with you and they are strange, I would suggest that you watch the previous 10 streams or videos. You'll be able to understand and catch up. Okay, so let's go on. Scaling an application. So they're saying you can create from the start a deployment with multiple instances using the replicas parameter for the kubectl create deployment command. Okay, so this sub command they're saying called replicas, that is a sub command, okay, to kubectl and can help us create replicas. So they're saying previously we created a deployment and then exposed it publicly using a service. So again, if you do not know what a deployment is and you don't know what a service is, you don't know how to create a service, you don't know how to create a deployment, and what a deployment is, what the difference between a deployment and a service is, please go ahead and watch the videos that I have in the playlist. Okay, you can check the description for them. Then we go on to say the deployment created only one pod for running our application. When traffic increases, we will need to scale the application to keep up with user demand. Okay, says the deployment created only one pod for running our application. Okay, that is clear. They say when traffic increases, we need to scale the application to keep up with demand. Okay, to keep up with user demand. And this makes sense because, for example, if we have maybe our one pod, okay, can only handle 10 requests. So if the request became 15, that one pod would crash because the 15 is beyond its capacity of 10. So we need another pod to serve the extra 5 users. So that's why scaling is very important. Now you're saying if you haven't worked through the earlier sections, start from Minikube. If you haven't worked through the earlier sections, start from using Minikube to create a cluster. And again, if this is your first time watching, yeah, heed to this advice. Okay, you need to create a cluster first of all. And I think I have those videos here, okay, where we create a cluster. Okay, was on day 2. Then also day 3. Okay, day 2 and day 3 have details about creating a cluster. So yeah, watch them and yeah, you'll get a lot from them. So let's go ahead. They're saying note, if you're trying this after the previous section, then you may have deleted the service you created or have created a service of type nodeport. Okay, you remember we learned about service of type nodeport. Okay, and they're saying in this section, it is assumed that a service with type load balancer is created for the Kubernetes bootcamp deployment. Okay, so it is assumed. And like we learned that load balancer is another type of service, just like nodeport. And of course, we have the default one that is called the cluster IP. Do not forget. So they're saying if you have not deleted the service in the previous section, first delete that service. Okay. And then run the following command to create a new service with its type set to load balancer. So that the service has to be deleted. Now, I'm not quite sure if we deleted it. Okay. If we didn't, of course, we shall delete. Excuse me, I got a cold. All right, so let's move on. So let me start. Let's see. Come back here. I seen this minikube service. I don't think we deleted it. Let me see minikube start. I'm not sure if I stopped it. Actually, I think this here actually shows that we stopped it. So let's start the cluster. After starting the cluster, I want to attempt to check if that. Meanwhile, as it loads, I'll say kubectl get services. Okay. And deleting shouldn't be that hard. If I get back, see in the previous section, in case you've forgotten the command, I didn't show you about it like me, you can always check the documentation. So you see, we have get services, that command. So then we expose the service of type node port. Okay. Then we add describe, just see the details. I'm looking for if we had anything like, we had deleting. Okay. We had deleting. So I'm not sure if I deleted it. Okay. So so you see we have Kubernetes cluster IP. We deleted it actually. Okay. Because at least if this is in the documentation, then I'm sure we walked through all the documentation and we executed this command. So that's good. And like you can see, it's not anymore here. Okay. We only have the default by Kubernetes of type cluster IP, which is only a service that exposes a node only within the cluster. So let's continue. So yeah, having here a new service. So they have the deployment. Okay. Again, if I come back here and I say kubectl get deployments. Okay, just to remind you, you see we have our deployment. Okay, a Kubernetes bootcamp. Okay, that's very good. Now we need to expose it as a service. Okay, so to learn, I'm going to type the command by hand, kubectl, because I realized I was starting to forget a few things we did last week. Of course, which is not bad. I can always check the documentation. So I'll say kubectl expose. So expose is what we use to create a service. Expose deployments. So deployments slash the name of the deployment, which is Kubernetes bootcamp, like that. Then minus type. Okay, don't forget that equals to load balancer. Okay, I'll just copy that. Type equals to load balancer. So after setting the type, you see we have the port being set here. Okay, you can say minus port 80. So we are simply exposing the Kubernetes deployment as a type of load balancer. Okay, so this will make it available to the external world outside the cluster, but also in addition to that, it will be able to distribute traffic between pods. Okay, so you can now what? Hit enter. So you see it says service Kubernetes bootcamp exposed. Now if I say kubectl get services, you see now we have the Kubernetes bootcamp, okay, load balancer, okay, service called Kubernetes bootcamp of type load balancer, and I actually can see the port at the end as port 8080. Okay, so this is great. This is great. Let's now I now want to continue to the next section, which is saying scaling overview. So in the scaling overview here, I'm seeing a diagram. Maybe I'll zoom out a little bit. Seeing a diagram, okay? So these are nodes, okay? And this is a deployment, okay? This is a deployment. This deployment has been exposed as a service. Okay, so it's called service A. You can see this is an IP address. Okay, so this dotted circle, let me just make it bigger. The dotted circle is representing the service. Okay, then here we have what? The actual, what is it called? The node. Okay, running the containerized application. Okay, so the service is being used to expose that application inside there. Okay, and we do that via the deployment. So let's move on. Saying scaling is accomplished by changing the number of replicas in a deployment. Okay. So they're saying scaling out a deployment will ensure new pods are created and scheduled to nodes with available resources. Scaling out a deployment will ensure new pods are created and scheduled to nodes with available resources. Okay. Scaling, then they're going on to say scaling will increase the number of pods to the new desired state. Okay. So they're saying Kubernetes also supports auto scaling of pods, but this is outside the scope of this tutorial. Scaling to 0 is also possible, and it will terminate all the pods of the specified deployment. Okay, that's nice. So if we say we need 4 pods, okay, and there are only 2, Kubernetes will make sure that we increase them to 4. Okay, and also it says that there's auto scaling. Okay, but they're not going to teach. We're not going to learn that now. I'll explain that ahead as we continue learning. There's going to be content concerning auto scaling. Okay, then also I'm seeing that you can scale to 0. Okay, that means of course terminating all pods. Okay, that would mean we have nothing to scale. Let's move on. Now they're saying running multiple instances of an application will require a way to distribute the traffic to all of them. Okay. Running multiple instances of an application will require a way to distribute the traffic to all of them. Then they're saying services have an integrated load balancer that will distribute network traffic to all pods of an exposed deployment. Okay. That is why I think we created one of type deployment. Okay. Right here, this type deployment. So they're saying there's an integrated what? Load balancer that is responsible for distributing traffic to all pods. Back then when I was studying about microservices and load balancing, I had to create a load balancer manually. But it's good to know that it's already built in. So they're saying services will monitor continuously the running pods using endpoints to ensure the traffic is sent only to available pods. Okay, this is good to know. Okay, so let's continue. They're saying once you have multiple instances of an application running, you would be able to do rolling updates without downtime. Yeah, that's good to know. Okay. So because in that case, I can decide to maybe like let's say if I had 10 instances, okay, I can roll out an update to one of them. Okay, when it is successfully, then probably roll out the update to the remaining 9, or maybe roll out to 2, then another 2, then another 3, like that until all the 10 are updated. But again, that is me speculating. We shall see in the section they're talking about, where we shall be studying about rolling out updates without downtime. Okay, and they're saying we'll cover that in the next section of the tutorial. Now let's go to the terminal and scale our application. Okay, so time for more practical, but I like this statement. It is very, very reassuring. When they say services will monitor continuously the running pods using endpoints to ensure the traffic is sent only to available pods. Very reassuring. I like that. So they say scaling a deployment they're saying to list your deployments, use the get deployments subcommand. Okay. So if you've been watching this from day one, okay, this is day 12. I expect you to be conversant with this, with what get is, okay, what kubectl is and what deployment is. So let's do it. I'll clear my screen and I'll type kubectl get deployments. Hit enter. They're saying server does not have a resource type deployments. And that is because of my stubbornness of not looking at the command properly. Okay, so this is the deployment we have, the Kubernetes bootcamp. Let's go ahead. Now they're saying the output should be familiar to, okay, familiar to something like this, okay, which we have seen, okay. And now as our age is 3 days, 23 hours, okay. That's how long they have had this deployment. And actually, I think we learned about deployments about 4 or 3 days ago. They're saying we should have one pod. If not, run the command again. So they're saying this shows name lists the names of the deployments in the cluster. So this is what they call a name. And in this case, we have what? Only one called Kubernetes bootcamp. They're saying ready shows the ratio of current / desired replicas. Okay. So here it shows that, so ready is the ratio of current to desired. So which means this first one shows we have one current replica, and this other one shows that we need only one desired. Okay. So the goal of the control plane and the class is to ensure that the current and desired are equal. Okay. And in this case, they are matching. Then after that, we have up-to-date display. They're saying up-to-date displays the number of replicas that have been updated to achieve the desired state. Okay. In our case, it's only one. Then they're saying available displays how many replicas of the application are available to your users. Okay. So we have here only one replica available and one has been updated to reach the desired state of one. Then they're finally saying age displays the amount of time that application has been running. Okay. For them it's 11 minutes. Okay. But for us here on my end, it is 3 days and 23 hours. Okay. That's the difference. Now, when I go on, they say to see the replica set created by the deployment, run kubectl get rs. Okay. kubectl get rs. Okay. And this is the replica set. Okay. So it's Kubernetes bootcamp with some random string here. Okay. Good. And actually, you can see the edge is exactly the same as the edge of the deployment. Now they're saying, notice the name of the replica is always formatted as deployment name random string. Okay. Just like we see here, this is the deployment name. Okay. This deployment, this name is the same as this one. Okay. So the deployment name, then a random string. And then they're saying the random string is a randomly generated. The random string is randomly generated and uses the pod template hash as a seed. Now they're saying two important columns of this output are desired and current. They're saying desired displays the desired number of replicas of the application, which you define when you create the deployment. This is the desired state. Okay, so our number of replicas we desire are only one in our case. Then it goes on to say current displays how many replicas are currently running. Okay, and in our case we have only one running. Then they're saying next, let's scale the deployment to 4 replicas. We'll use the kubectl scale command, followed by the deployment type, name, and desired number of instances. Okay, so we're going to create 4 replicas. Okay, we'll use the kubectl scale command. Okay, followed by the deployment type. Okay, name. Okay, and desired number of instances. Okay, so yeah, I like how their commands like make sense. Okay, that if I'm using get, I now want to list something. If I use something like create expose, okay, I know I'm exposing a service on a deployment. Very good. Now here we have another command called scale, okay, which makes sense. Okay, just a moment. All right. So you're saying kubectl scale, then we can mention the name of the deployment to scale, and then the number of replicas. All right. So I'll clear my screen. Just a moment. Looks like I've messed up my hand. All right. kubectl expose. Okay. So after expose, I named the deployment. In fact, I'll first say kubectl get deployments. Okay. Because I want to copy this one here. Okay. Copy it. No need to memorize anything in any case. Of course, by now, maybe I should know that it's Kubernetes-bootcamp, okay? Because we have typed it over and over again. kubectl expose, okay? Deployments, deploy. Can I spell deployments correctly? / the deployment name. Then I say minus, okay? Replicas, or the number of instances equals to 4. Now, if you realize I've made a mistake, expose is when you're creating a service, okay? This is supposed to be scale, okay? I'm supposed to scale, not expose. So this should be it. I should now hit enter. And now you see deployment.app/kubernetes-bootcamp scaled. Great success. I love this. So if we come here, they're saying to list your deployments, once again, use get deployments. Okay. So shall say the previous command, kubectl get deployments. Aha. Nice. Okay. So we have now, I see now the current state that we have 4. Okay. We have 4 instances running. It's the current state, and the desired state is 4. So our current state matches that current state. How many replicas were updated to reach the desired state? 4 were updated. Okay. How many replicas are available? 4. Okay. What's the age? So the time when it was created is now 4 days. Okay. So pretty interesting. Okay. Now they're saying the change was applied and we have 4 instances of the application available. Next, let's check if the number of pods changed. Okay. So you're using a new command called get kubectl get pods -o wide. I want first of all to run get pods without the -o wide to see. Just remind myself kubectl get pods. Okay. Okay, this makes sense. Now we have 4 pods. Okay, very nice. Okay, and like you can see, this first one was created about 17 minutes ago. Okay, it was restarted about 17 minutes ago 3 times. Okay, and yeah, the others 0 times. So yeah, this makes sense because actually when you what I like about this, that's why they explain about deployment. That when you create a deployment, okay, automatically pods are created for you under the hood. Okay, and they're managed for you. This is really nice. I love this. Okay, so you see we have now 4 pods. Okay, so now we can do what they did. I can clear the screen and now say kubectl get pods -o wide. Okay, and there we are. Okay, so let's go on. So they're saying there are 4 pods now with different IP addresses. Let us see these 4 pods with different IP addresses. There's so you see we have the name, okay, there's name, age, IP, the node, nominated mode, the ready status. The IPs are here. Okay, this is an IP for the first one, IP for the second one, IP for the third, IP for the fourth. If you can see actually the values, okay, each of them start with 10, 2240, 10, 2240, 10, 2240, 10, 2240, okay. Then what changes the number at the end, okay? 22, 24, 25, 23. Pretty cool. And what are the status? All of them are running. So we shall be able to have load balancing. Okay. But remember, to achieve this, we had to first of all expose a service of type load balancer. So let us go on. They're saying the change was registered in the deployments event log. To check that, use the describe sub command. So to do this, thing you can say kubectl describe the deployments Kubernetes bootcamp. Okay, this should not become second nature to us. Okay, so I'll come here, clear the screen one more time, and type kubectl. Okay, describe. So in the describe, I'm looking for that information. We have the name, the namespace, the creation timestamp, labels. Remember, we learned about labels. Okay, annotation selector, replicas. Okay, so you see what we have. They're now saying 4 desired replicas, 4 updated, 4 total, 4 available, 0 unavailable. Isn't this what we're interested in? All right, we are moving on steadily. Actually, look at this down here. Look at this interesting text. They're saying no more scaling replica set. Okay, deployment controller scaled up replica set Kubernetes bootcamp from 1 to 4. Interesting. Now they're saying you can also view in the output of this command that there are 4 replicas now, and that's what we've just seen. Now let's move on. They're saying load balancing. Okay, they're saying let's check the service. Let's check that the service is load balancing the traffic. Okay, to find out the exposed IP and port, we can use describe service as we learned in the previous part of the tutorial. Okay, let's check this. Let's check that the service is load balancing the traffic. To find out the exposed IP and port, we can use describe service as we learned in the previous part of the tutorial. So this describe, because you can use to describe deployment, describe a pod, describe a service. Okay, so I copy this, clear my screen, paste the command, and there we are. Okay, we have similar information: the name, the namespace, the labels, annotations, selector, the type. You see, is load balancer. The IP, IPs, the port, target port, the node. Okay, endpoints. Okay, let me see. This is 1, 2, 3. Okay, plus 1 more to make 4. That makes sense. Let's go on. They're saying create an environment variable called node port that has a value as the node port. Okay, so this is what they're doing. Okay, they are fetching from, they first of all get the services. Okay, then they pass a template. Okay, the index, specs, ports. Okay, then they get the node port, and then they store it in this environment variable. Okay, then they simply print it. So I'll copy, but this is it is important to actually have some basics, okay, of shell commands, by the way. Okay, you need to have basics of shell commands to understand this. Sometimes, actually, I would suggest before anyone learns things like Kubernetes, Docker, maybe you know some shell commands. Okay, it will help you. Now we move on. They're saying next we'll do a curl to the exposed IP address and port. execute the command multiple times. Okay, so I'll copy this, paste. Okay, of course this wouldn't work because of what they told us last time. Okay, because we are using Docker, okay, as the engine, this wouldn't work. Okay, but if you watch the previous tutorials, there's a way around that. Okay, so they're saying we hit a different pod with every request. This demonstrates that the load balancing is working. The output should be similar to, you see, stuff like this. Okay, there is this. Okay, so if I show you, if you look at this, okay, these pod names, okay, they are different. Okay, if you look at this random string at the end, they are different. Okay, they're different. Okay, so then now they're showing us the same way. Okay, because now you see, if when we run this, okay, here it won't work. Okay, and they're going to explain it in a bit. I've seen it ahead here. They are saying not if you are running Minikube with Docker Desktop as the container driver, a Minikube tunnel is needed. Okay, and like in my case, I showed you last time, I am using Docker Desktop as the container driver. So we need a Minikube tunnel. Okay, and they're explaining why do we need a Minikube tunnel. They're saying this is because containers inside Docker Desktop are isolated from your host computer. Okay, they are isolated from our host computer. All right, so they're saying in a separate terminal, execute Minikube service, okay, kubernetes-bootcamp URL, okay. So I can maybe do it here, okay, clear this. I say Minikube service, okay. What service? Service name is kubernetes-bootcamp. Probably I need to cram this tool. It is Minikube service. And take note, this is a command on Minikube, okay, not kubectl. Just create a ton of kubernetes-bootcamp -- URL. Okay. So they're saying, yeah. So this is the URL. And look at the message. They're saying because you are using a Docker driver on Darwin, the terminal needs to be open to run it. Okay. So we have opened the terminal. Okay. So now we can now go and see the output looks like this, which is what we get. Now they're saying then use the given URL to access the app. Okay. So now we can use our URL and run it 4 times. Okay. Even more than 4 times. We should expect what? In every request, okay, it to be hit with a different pod, which is load balancing. So now if I copy this URL, I clear the screen, can say cal, paste, that's the first time, okay, paste again, okay, this, okay, I made a mistake, I have to put a cal, okay, then again cal, okay, then again cal, okay. So if you watch this, I mean, if you read this, you'll see that we are using different pods, okay. This is a pod with a different hash, okay. This one is also a different pod. Look at the hash at the end, okay. Actually, it ran the same like the first one, okay. Then here it then changed, okay. Then here it changed to a different pod, okay. So it's load balancing in action, okay. Every time we access, we are using a different pod. If I say cal again, you see now this is a different pod which has been used, okay. Clear the screen, try again, cal, you see. So these last year the same pods, okay. These have been the same pods, but the first one was different. I'll run it again. Okay, now a different pod, the same pod, different pod, different pod, different pod, the same, different. Yeah, and that's what load balancing is all about. Okay. Okay, so we are done. Okay. I should probably always remember this. Okay. Simply use service and expose the URL. But of course, I can always check the documentation. Now, the next step is to scale down, okay? And they're saying to scale down the deployment to 2 replicas, run again the scale subcommand, okay? So, but we changed, what I'm seeing here, the difference is that the value for replicas is now 2, okay? So I'll copy this name. So it will be kubectl scale, okay? What are we scaling down? The deployments minus replicas equals to 2. Okay, so they've been scaled. They've reduced them from 4 to 2. So they're saying list the deployments to check if the change was applied with the get deployments command. So cube, I've realized sometimes instead of copying and pasting, it is better to type the code, the commands out. Get deployments. It helps actually. It's better to type out the commands and make as many mistakes as possible. Okay, so now you see we have only 2 available nodes. Okay, and our desired state is 2. Our current state is 2 nodes. Okay, so if I say cube ctl get pods, I should see only 2. Okay, very good. Okay, if I, of course for the services we should expect the same thing, get services. I know you might be thinking, why don't we try services too? Okay, but we still have only one service, which is the type load balancer. So I clear that, and now they're saying the number of replicas decreased to 2. List the number of pods with get pods. Of course, we can do that. kubectl get pods minus o wide. Okay, there are only 2. Okay, so you see we only have that one at IP ending with 22 and another one ending with IP 23. So it says this confirms that 2 pods were terminated. Okay, what a good day of learning. So great success. So just to move through what we have studied today is that we have looked at scaling an app manually using kubectl. This should let us know that there is a way of scaling an app automatically. And that's what I look forward to. Then there is they're saying to be able to do that, okay, we need to expose a service, okay, of type load balancer. And that was explained. Okay, we need to create a service of type load balancer, and that was explained in the previous videos. Then so they're saying scaling is accomplished by changing the number of replicas. And we did that, okay? We first got the deployments that were available, okay? After that, we got the replica set, okay? Then we scaled to 4, okay? After scaling to 4, we tried to test out load balancing, okay? We tested out load balancing by running the application 4 times, about 4 or 5 times, okay? In a number of times, okay? But the goal was to see that the requests are coming from different pods, okay? Almost every time. And then after that, we scaled down, okay? We were scaling down, okay, to 2 replicas. So thank you for learning with me. Good progress you have made. See you in the next